At inverse trig functions. So, if you think about like the sine and cosine functions as being waves, you'd think, oh, it doesn't have inverse because it doesn't pass the horizontal line test. But if we restrict the domain and only take like a chunk of it, and that is not even the right chunk, then it passes the vertical and horizontal right here in that little chunk. And that's just one example. So let's look at graphing the original functions, and then all inverses is you switch the inputs and outputs. So sine starts at 0, 0. At negative pi over 2, sine is negative 1. And at pi over 2, sine is 1. So I kind of have this part of sine. And so arc sine, or sine to the negative 1, I mean that inverse here, we just switch the inputs and outputs. So it's still going to be at 0, 0. But now this time, instead of the point negative pi over 2, negative 1, and pi over 2, 1, we switch them. So we have 1, pi over 2, and negative 1, negative pi over 2. So it almost looks the same. Almost. Our domain for sine is the restriction here. So negative pi over 2 to pi over 2. The range is negative 1 to 1. And it switches when we do inverse. So domain is negative 1 to 1. And range is negative pi over 2 to pi over 2. Okay. Cosine. Let's try the original cosine. At 0, it's 1. Pi over 2, it's 0. And at pi, we're at negative 1. So it looks something like that. Our domain comes from here, from 0 to pi. And the range is negative 1 to 1. So we can go ahead and switch that here. So negative 1 to 1. And 0 to pi. And then we will switch the ordered pair. So instead of 0, 1, and pi over 2, 0, and pi, negative 1, we'll switch them. So 1, 0, 0, pi over 2, and negative 1, pi. Kind of connect them like that. All right, tangent. Negative pi over 2 to pi over 2, which we know that's the new range here. Negative pi over 2, pi over 2. And then tangent, we got 0, 0. At pi over 4, got 1. And negative pi over 4, you get negative 1. So tangent looks something like that. So then we can switch the points. So range is actually all real. So domain is all real. Still going to be at 0, 0. But now, instead of pi over 4, 1, and negative pi over 4, 1, we switch it. So 1, pi over 4, and negative. Should be negative 1. Negative 1. Negative pi over 4. Kind of looks like that. Not exactly linear, but almost linear. Okay. Now so let's look at evaluating some. So think of the unit circle and evaluate the trig functions. But remember the domain and ranges of them when we have them restricted, because some of them might not work out. So if you think of and arc sine being it's switched, arc sine of 1 is when we want the output of sine to be 1. And that happens here. 0, 1, sine is y. So we want the input. So the input is pi over 2. All right. Now this next one, we want an output of root 3 over 2. And I'll just draw part of it here. I know that's pi over 4, and that's root 2 over 2, root 2 over 2. And I know that's 1/2. And I don't know that. That's root 3 over 2, 1/2. And this is 1/2 root 3 over 2. So, and then this is pi over 6, pi over 3. So, when the y is 3 pi over, when the y is square root of 3 over 2, the input is pi over 3. Arc sine of -2. Well, I don't have an output of -2 on the unit circle. And my inputs for the inverse is -1 to 1. So, it doesn't exist in our domain. Now let's look at cosines. Now we're looking for x values. So the x value. So when is the x value? Negative root 2 over 2, and that's when it's in this quadrant. See, pi over 4, 2 pi over 4, so 3 pi over 4. Kind of same deal with this one. The domain of arc cosine is from -1 to 1. So that's not within the domain, so it doesn't exist. And then -1, we want when the x is -1, so that's over here, at pi. Now look at tangent. This one's a little hard to think about because tangent is sine over cosine. So we want sine over cosine to be root 3 over 3. And when I think about the unit circle, I can't think of any fraction that has a bottom of 3. So what that tells me is I had to rationalize the denominator, and that means that root 3 had to have been in the denominator. So sine over cosine. That would be here. 1/2 divided by root 3 over 2 is really 1/2 times 2 over root 3. So the 2's would cancel, and then you'd have root 3 over 3. So at pi over 6. Right? Arctan of -1. Right? Gotta think about this one. Okay, so the times that sine over cosine is 1. Pi over 4 in the middle. 3 pi over 4, middle, and middle again. Trying to think domain here. Arctangent. So domain is all real numbers. And the range is from negative pi over 2 to pi over 2. Okay, so this 3 pi over 4 is not in the domain of arctangent, but pi over 4 is. But if I do pi over 4 here, it gives me a positive 1. I need it to be negative 1. So what I can do is go the opposite direction and go negative pi over 4. Because then I'll be down here in the 4th quadrant, and it will work. And negative pi over 4 is in the domain. All right, and then we want, when is it going to be root 3? So this time it's going to be at this one, because you have root 3 over 2 times 2, the 2's will cancel out. So pi over 3. All right. A ship left port A, sailed due east to port B, 60 miles. From port B, we went 120 northwest and stopped at a point directly north of A. Find the bearing from port B to the ship's current location. Okay. Move this over. So bearing is this piece right here. So what I need to do is find this theta here and then subtract it from 90. So I have adjacent and hypotenuse. That goes with cosine. So cosine of theta is 60 over 120, which 60 over 120 is 1/2. So the way we can solve this is take the inverse cosine, which you can either see written like that, or you can see cosine negative 1. So we want to know when is, and this happens at we want to know when the, gosh, I'm like confusing myself over here. I might have to throw that in the calculator. So arc cosine of both sides, using with theta as arc cosine of 1/2. Or you can think of cosine, and cosine theta is 1/2 when we have pi over 3 or 60 degrees. So we can use that, subtract that from 90. So 90 minus 60 is 30. So 30 degrees. All right. The angle of elevation, oh, we got a nice little picture over here. Football field to a crossbar goalpost depends on the distance from the ball to the base of the goalpost. Write theta as a function of d. So this is opposite and adjacent. So that's going to go with tangent. So we would have tangent theta is opposite over adjacent. But if we want to find theta, we just do the inverse. So tangent negative 1 or arctangent of 10 over d. Using a calculator, find theta when d is 75. So, tangent -1, 10 over 75. Oops. So I get 7.59, so 7.6. And we're in degrees. All right, 2 cables are secured from the top of a 50-foot tall utility pole to the ground. Lengths are given as C1, C2. Right, theta is a function of C1, C2. Okay. So I need to do the whole angle, subtract off this piece. So the whole angle, let's just call that A and call this B. The whole angle, we know that that's 50. So we know adjacent and hypotenuse. So cosine of A is 50 over C1. So if I were to solve for angle A, you'd have to do the inverse cosine. So A is inverse cosine 50 over C1. And then B is going to be the same thing. So cosine B 50 over C2. So B is cosine -1 50 over C2. And then we just do A minus B. So theta is cosine -1 50 over C1 minus cosine -1 50 over C2. Use the calculator to find it if the cables are 120 and 65 feet long. So this one's the longer one. So cosine -1 50 over 120 minus cosine -1 50 over 65. So let's see what that gives us. 50 over 120 minus 50 over 65. So I get about 25.66, so 25.7 degrees. Okay. Now let's look at graphing them using transformations. All right, and the way we can do this is two ways. So we can use our, we can go back to this idea of a guide function, and we can find the inverse of what's given, and then use that to get some key points. And then we just switch the inputs and outputs. So the inverse of this, well, let's see. What we have is y equals arc sine of 2x. To find the inverse, you switch x and y, and then solve for y. So y is within the trig function, so I have to undo the trig function by taking the sine of both sides. So sine of x equals 2y, and then I can divide both sides by 2. So what I have as my guide is y equals 1/2 sine of x. And then remember, we can restrict the domain of sine to being -pi/2 all the way to pi/2. So if we just do some equal steps here, you get -pi/4, 0, pi/4. Let's evaluate it at sine. So sine of -pi/2, I think unit circle would be here. So sine is -1. So times 1/2 is -1/2. And then let's see, -pi/4 is that middle one. It's -√2/2, but dividing it in half. So we actually get -√2/4. Sine of 0 is 0. 1/2 of 0 is still 0. And then pi over 4 and pi over 2 are going to be the same as the others, just positive. But now we switch them to graph. So this is the new x and this is the new y. So negative 1/2 and negative pi over 2. 0, 0. I'm going to do the easier ones. And then 1/2 and pi over 2. The others are going to be somewhere in the middle, so I'm not even going to try and plot them. Looks something like that. All right, let's do a cosine one. So we have y equals inverse cosine of x minus pi. Let's switch the x and y and solve for y. So I can add pi to both sides. And undo the inverse cosine, I can do the cosine of both sides. So cosine x plus pi is y. And let's see the cosine one. It was from 0 to pi. So 0 to pi. I wonder, does that matter? Okay, I was going to start at doing 0 to pi as the coordinate points. But if we have a little shift here, we go left pi. So if I go ahead and just shift it left, then I can get the values I need. I don't have to like use 0 first and then shift it, plug it in, and all that fun stuff. So let's shift it and then get the values. So pi over 4, negative pi over 2, negative pi over 4, and 0. And then let's get the values. All right, so negative pi would be going around, because this would be 0, pi over 2, pi, 3 pi over 2. So going the opposite way would make it here. So the point is 1, 0. So cosine is 1. Negative 3 pi over 4. Normally it's here. So going backwards, it's going to be here. So the x is negative root 2 over 2. Negative pi over 2 is going to be here. The x is 0. Negative pi over 4 is this middle one. The x is... Alright, I don't know why my thought process of negative pi over 4 being here, because that would give us root 2 over 2, negative root 2 over 2. The answer is negative root 2 over 2. So I don't know why this thought process is not working, because it'd have to be this. But if I go from the original and think, instead of being left pi over 4, left pi already. So the original would be pi over 4. I'm trying to think if I added pi back. So 1 pi over 4. Oh no, it'd be 3 pi over 4. Because adding 4 would give me 3. So the original would be here. And going to the right, or left, going to the left. And moving it opposite ways. Okay. Can I just plug this in a calculator and get the right answer? Probably. I have to come back to that idea. I don't know why it worked everywhere else, but it didn't work. Oh, and it didn't work on this one either, because that's supposed to be a positive pi over 2. Or positive root 2 over 2. Because the negative, doesn't the negative just tell us the direction? Alright, I gotta come back to that idea. And then 0, I'll give negative 1. So all of them are going in this direction. So 0, negative pi over 2, negative pi, negative 3 pi over 2. Oh, because even this, though, this would be negative 1. Why is it the cosine ones that always give me the most trouble? Because the only thing I can think of is that it's just a mirror image of what we already have. So if I leave it at what we have and just think mirror image of it, pi is here, but mirror image would be over here. Negative 3 pi over 4 is here, but mirror image is over here. But even then, though, negative 3 pi over 4 is not. 3 pi over 4 is here, so mirror image would be here. And then pi over 2, but then negative pi over 2, and then negative pi over 4 is this. Negative pi over 4 is this one. So the mirror image would be here, which would make it negative. And then 0 is here, but mirror image is over here. That's the only thing I can think of with the negatives being different. So I wonder if that's going to happen every time. And we'll find out as time goes on. Okay. So now I plot them as this is x, this is y. So 1, negative pi, 0, negative pi over 2, negative 1, 0. So it'll look something like that. All right, let's do a tangent one, and then be done. So, y equals arc tangent x plus 2. So x equals arc tangent y plus 2. Got to do tangent of both sides. And then subtract 2. So tangent of x subtracted 2. So just shifted down 2. So let's see. Negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. So remember, we have some vertical asymptotes. At 0, it's usually 0, but down 2 means here. And the others are at 1. So negative 1 down 2 is negative 3. And 1 down 2 is negative 1. And then we can plot this as x, this as y. So undefined is usually 1 over 0. So when I switch it, it's really 0 over 1. So at negative pi over 2. We're at 0. What am I doing? Let's not do that. Plot. Let's plot the ones I know. So negative 3 and negative pi over 4, which is here. Negative 2, 0, and negative 1 pi over 4. Like something like that. And there we have it.